liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
The conclusion we've come to is that there's a significant spherical aberration appears to be present in the optics. A very aggressive set of movements were made. Should have significantly improved the image, but it did not. It did not.
Can we do unique and important science? The answer is an emphatic yes. And nobody's walking away.
All right, you gotta go for release. Hey, no hands.
For a decade, NASA's Hubble Space Telescope has been orbiting above Earth, capturing light, helping humans see and study distant realms. It's as though we all have gone on a 10-year voyage of discovery, far away and nearly to the beginning of time. In 1994, after the telescope's optics were corrected, the Hubble witnessed a unique event in human history. Carolyn Shoemaker made the discovery using a ground-based telescope at Mount Palomar with team members husband Gene and colleague David Levy.
I don't know what I've got. It looks like a squashed comet.
In July of 1992, a comet passed so close to this giant planet that it was split apart into approximately 20 fragments.
And so began a global adventure to track Comet Shoemaker-Levy like a runaway freight train barreling into Jupiter. Scientists hope to have a good view to learn about the nature of comets and the atmosphere of Jupiter. But this comet went way beyond expectations.
It's happening tonight. We have a fully repaired and healthy Hubble Space Telescope, which has been performing like a jewel in the last few months.
We were fortunate to have the Hubble in the right place at the right time to be able to capture this one. That large ring, that big smudge, you could easily fit the Earth inside that diameter. This is one big impact site.
Observers watched for impacts using telescopes all around the globe, but they could see the best details using the Hubble. In hundreds of images, the Hubble has given the world both discoveries and a universe of beautiful pictures. Some of the most popular Hubble images are stunning new views of known objects. Hubble's eyes provide greater understanding of objects that have long tantalized astronomers.
What Hubble lets you do is to see the details of those objects, to see them at the level that you can understand the physical processes that are giving them their shape and their character.
Whether with the visible light that we can see or the light from the spectrum that we can detect, Hubble gives astronomers better eyes. With those eyes was confirmed a theory that seemed like science fiction, a supermassive black hole in a spiraling disk at a galaxy's center.
Nature has wonderful surprises, and this disk is far more interesting and revealing than we expected or imagined. Much to our amazement, the disk shows spiral structure. We were very excited about finding the disk because it provides a new and simple way to make a decisive test for the presence of a black hole in the center of M87.
These are the most definitive measurements that show how that disk in fact is spinning. We're basically looking to see how fast is something moving toward us or away from us. The speed that we actually measure is coming toward us at 1,000,000 miles an hour. One coming toward us, that speed, one coming away. So this thing is really rotating. If this thing is just gas, what's holding it together? Why doesn't it just fly apart? And the answer is very straightforward. It requires a very strong gravitational field to hold all this together. There truly are billions and billions of stars that have collapsed inside and been eaten by this black hole.
In the next years, there were more large galaxies with more supermassive black holes to see. With the use of a new, faster spectrograph, STIS, Hubble became a black hole hunter. The Hubble Space Telescope was put in orbit above Earth's atmosphere to penetrate the mysteries of the universe. Hoping to see the earliest form of galaxies, the Hubble Deep Field team took the deepest look ever of the sky. The team pointed the telescope at one tiny spot in the sky for a 10-day-long exposure, accumulated data, then added 3 filters together into one full-color image.
We look as far down that image as we can, and we still see galaxies. And if we count the number of galaxies looking back in time, we still see that number increasing. And so that sets a very exciting constraint that says that galaxies turned on when the universe must have been very, very young.
One of the great legacies of the Hubble telescope will be these deep images of the sky showing galaxies to the faintest possible limits with the greatest possible clarity from here out to the very edges of the universe.
Using Hubble, astronomers saw galaxies at the edge of the universe. To measure the expansion rate and estimate the age of the universe, astronomers observed Cepheid stars and used other distance indicators.
It's a pleasure today to announce our final results from the Hubble Space Telescope key project to measure the expansion rate of the universe. We have used the Hubble to measure distances to spiral galaxies using a particular kind of star known as a Cepheid. The brightness of a Cepheid is directly related to how fast the brightness changes. It provides a very accurate measure of the distance to the galaxy. Our final result is a value of 70. This value of 70 yields an age of 12 billion years.
It's come to a culmination now. How do you feel right now?
I think with the Hubble Space Telescope, we have achieved what we set out to do, which was to measure a Hubble constant. So I have to say, it feels great.
By measuring the Hubble constant, you measure how far away the galaxies are. You can answer the question, how long the universe has been expanding. And by looking at very distant objects, you can even ask the question whether the expansion that we see near us has been speeding up or slowing down over time. And that helps you answer the profound question whether the universe will expand forever. So there are a lot of things at stake here. It's not just a number.
The results discussed today, I see them as the first acts in a grand cosmological drama that's going to play out over the next 2 decades.